Hello students, welcome to Engineers Academy. Kindly subscribe my channel if you haven't subscribed it yet. Now we are going to solve these two problems which are a little bit different from each other, right? So the problem statement says that the 0.8 megagram car travels over the hill having the shape of parabola. If the driver maintains a constant speed of 9 meters per second, determine both the resultant normal force and the resultant frictional force that all the wheels of the car exert on the road at the instant it reaches point A. Neglect the size of the car. So in the first problem statement, it is said that the car is moving with a constant speed. So if it is moving with a constant speed, and if we are solving this problem by using the tangential and normal coordinates, then the tangential acceleration is equal to 0. And in the second problem statement, it said that when the car is at point A, it is traveling at 9 meter per second and increasing its speed at 3 meter per second square. So now in this particular case, the tangential acceleration is equal to 3 meter per second square. So this is the only difference in both of these problems, right? Now, if the car is at point A, let's say, if the car is at point A, and let's say that this is the free body diagram that we are assuming. Let's say that somewhere here is that point A. Let's say this is that point A. So let's assume that this is our tangential axis, like this. Tangent to the path is our tangential axis, and towards the center of the path is our normal axis. This is our normal axis. So if I extend this normal axis like this, so the weight of the car will be acting vertically downward. So this will be the weight of the car like this. This will be the weight of the car which will be acting vertically downward. And it will be making some angle theta here. And the frictional force on the wheels of the car by the surface will be acting in the opposite direction of the motion, right? So the friction force will be acting in the negative tangential direction. So this is that frictional force. And the normal force will be acting by the surface in the negative normal direction. So this will be the normal force. So we are required to find this N and this frictional force. Now we need to have this angle theta. So we need to find this angle theta at point A. So at point A, if I draw a tangent line, at point A, if I draw a tangent line like this, and if we assume a small triangle like this, and if this is that angle theta, so we can find this angle theta if we consider that this is dy, this is the small change in the y coordinate, and this is the small change in the x coordinate. So we can apply tan theta. So if I apply tan theta, so tan theta is dy by dx. And we are given the path as a function of x. So we can take the first derivative of this, and then at A, the x coordinate is 80 meters. So we can put x value, once we take the first derivative, then we need to put x value 80 meters, then we will be able to find dy by dx. And then we will be able to find the angle. So once we find this angle, if I draw that normal axis is here at point A, this is that normal axis. And if I draw a vertical line along which the weight is acting, so this angle is between this horizontal and this tangential axis. So if this normal is perpendicular with the tangential axis and this vertical line is perpendicular with the x-axis, so if the angle is, the angle here is theta, if this angle is theta, then this angle is also theta. So this means that if we find this theta, then that weight will be making that same angle theta with the normal axis. So this is that theta. So we are required to find this theta since we cannot find this f and n once we find this theta, since we need to resolve this weight into its components. Now the second thing that we need to find in this particular problem is the radius of curvature, since we are going to deal with the tangential and normal axes. So the normal acceleration is v squared divided by rho, the radius of the curvature. So at point A, we need to have this radius of curvature value, and once we are given y as a function of x, so we need to find that radius of curvature using this equation that we have learned in the previous chapter. So first I will find this radius of curvature. So to find this radius of curvature, we need to find the first derivative of that function, and then we need to find the second derivative. So we are given that y is equal to 20 into 1 minus x squared divided by 6400. So if I take the first derivative with respect to x, so dy by dx, this is constant, and the derivative of 1 is 0, and the derivative of this is minus 2x divided by 6400. And when we simplify this, 0 minus 2x divided by 6400 will be this thing, and then if I multiply this, so this is 40 divided by 6400. So 40 divided by 6400 is 1 divided by 60. So we can say that this is minus 1 divided by 160 into x. So this is dy by dx. And when x is equal to 80 meters, we can find dy by dx. At a, the x value is 80 meters. So minus 1 divided by 160 into 80. So this gives me 80, 160 divided by 80 is 2. So this is minus 1 divided by 2, and minus 1 divided by 2 is minus 0.5. So this is dy by dx. So the dy by dx is this thing. Now if I take another derivative, so this will be d square y by dx squared. So the second derivative of this with respect to x is minus 1 divided by 160. Now we can find the radius of curvature by using this equation. So I will write that radius of curvature rho, and that is 1 plus dy by dx value, and then we need to take the square. So dy by dx at x equals to 80 is minus 0.5. So I will write minus 0.5 square, and then to the power 3 divided by 2 divided by the absolute value of the second derivative. So the absolute value of the second derivative is 1 divided by 160. So 1 divided by 160. So we can find it using calculator. So this is 1 plus 0.5 square to the power 3 divided by 2 is 1.5. And this is 1 divided by 160. 1 divided by 160. So this is 223.61. 223.61 is the radius of curvature at point A. And we can find that angle, that tan theta equals to dy by dx, and now we know that dy by dx is minus 0.5. So we can say, let me write it here, that tan theta equals to dy by dx, which is equal to minus 0.5. So we can say that theta equals to tan inverse minus 0.5. So tan inverse minus 0.5, this gives me minus 26.57, minus 26.57. So the minus sign means that the curvature at point A is making, or we can say that at point A the tangential axis is making 26.57 degree angle in the clockwise direction. So this angle is 26.57. So this is that theta. So now we know this theta. This theta is 26.57 degrees. So now we can resolve these forces. We can resolve this weight into its components. So this weight will have two components. We will have one component here. This will be the cos component. This will be W cos of theta. And we will have one another component like this. This will be W sine of theta, which will be acting in the positive tangential direction. And we can find that weight. We are given that the mass is 0.8 megagram, right? So in kgs, the mass is 0.8 into 10 raised to the power 6 grams. And if we divide it by 1000, so this will be 0.8 into 10 raised to the power 3. Or we can say that it is 800 kgs. So the mass is 800 kgs. So the weight is 800 into 9.81. So the weight is 800 into 9.81. So this 7848 Newton is the weight of the car. So now if we apply the kinematics equation, so if I apply the, let me keep this aside here, right? So if I apply the summation of forces along the tangential axis, so that will be equal to MAT. So now as we can see that this sine component of the weight is acting in the positive tangential direction. So the weight is 7848, so I will write 7848 sine of theta, and theta is 26.57 minus this friction force which is acting in the negative tangential direction. So this will be equal to mass times the tangential acceleration. So for the first problem, the tangential acceleration is 0. So if the tangential acceleration is 0, so then this will be 0. Right? So we will have 0 on the right hand side of this equation. Or from this we can say that the friction force is equal to the sine component of the weight. So I will say that the resultant frictional force on the wheels of the car is equal to the sine component of the weight. So I can say that is 7848 sine of 26.57. So this is 3510 newtons. 3510 newtons. Or we can say that it is 3.51 kilonewtons. And now if I apply the summation of forces along the normal axis, so that will be equal to MAN, and the cos component is acting in the positive n direction, so I will write plus 7848, weight is 7848, cos of theta, theta is 26.57. The normal is acting in the normal reaction is acting in the normal axis, in negative n axis, so I will write minus n, and this will be equal to mass. So the mass is 800 times the normal acceleration, and the normal acceleration is v square divided by rho. And when the car is at A, in the problem statement it is said that it is moving with a constant speed, it is 9 meters per second. So we can find this AN. So AN is 9 square divided by rho, and rho value is 223.61 that we have determined, 223.61. So that normal acceleration is 0.362. So now I can put that value in this equation. So we can write that this is 7848 cos of 26.57 minus n, and this is 800 times an, which is 0.362. So we can find this n. So if I bring this n to the right hand side, so this will become positive, and if I bring this to the other side, so it will become negative. So we can say that n is equal to 7848 cos of 26.57 minus 800 into 0.362. So 7848 cos of 26.57 minus 800 into 0.362. So this gives me 6.729, or we can say that it is approximately 6730 Newton. Now if someone want to find the answer of the second problem, in which the tangential acceleration is 3 meters per second square, so we will have the only difference in this equation, right? So again I will write this equation, we will have the same equation, but the right hand side will not be equal to 0, right? So I can write that for the second problem, we can write that this is 7848 sine of 26.57 minus friction force, and this will be equal to mass. So the mass of the car is 800 into tangential acceleration, and the tangential acceleration is given in the second problem, which is 3 meters per second square. So now we can find f, so I can bring this f to the right hand side, so it will become positive, and I can bring this to the other side, so it will become negative. So we can say that the frictional force is this sine component minus 800 into 3. So 7848 sine of 26.57 minus 800 into 3. So the resultant frictional force on the wheels of the car by the surface for the second case is 1110 newtons. So the only difference will be in the resultant frictional force, since the second equation will remain the same. So the resultant normal force on the wheels of the car for both the cases is 6730, and in the first case, when the tangential acceleration is 0, the frictional force is 3510 newtons, and in the second case, the resultant friction force on the wheels of the car is 1110.